Now, as we did the Mendeleev periodic table, and I told you the many drawbacks that it has, but still I told you that it played an important role that in chemistry, that he was able to classify 63 elements, but still due to limitations we needed a periodic table that can fulfill the limitations or can fulfill the answers that were left by Mendeleev. So that was called as the modern periodic table. But before the modern periodic table came, the scientist Moseley was the one who said that instead of atomic weight, if an atomic number is considered as a fundamental property, that means if instead of taking an atomic weight by arranging the elements according to the increasing weight, if we'll arrange the elements in order of increasing atomic numbers, we'll get to see the more periodicity in the properties, and it really happened, and this led to the formulation of modern periodic law. It states, as the Mendeleev stated in his law, that the properties of an element are periodic function of their atomic masses. So likewise, there is the modern periodic law which states that the properties of an element are periodic function of their atomic numbers. That means if an elements are arranged in order of increasing atomic number, we'll get to see the periodicity in the properties. That means if any physical or chemical property, there will be a regular gradation in it. So this law actually led to the foundation of the modern periodic table by Niels Bohr. So the table consists of groups and periods. Group and periods as was taken by Mendeleev. So the groups were the vertical columns. So how many groups this modern periodic table has? It has got the 18 groups. It was actually a well defined tabular form which contained all the elements at places very beautifully arranged, and similarly the period, the 7 number of period it has. So the modern periodic table has got 18 groups and 7 periods. Out of 18 groups, some period was given the specific name, otherwise we can call them as the family by prefixing the name of the element which is present as the first element. So for the first group, the name is alkali group, which comprises of lithium, sodium, like that, the group 1, and the group 2 was called as alkaline earth metal group. Likewise, we have the name for the 17th group. These are the important groups that I am telling you. You need to remember them. They are called as halogens. That means salt producers. 18th group was given a name, that is inert gas group or noble gas group, because it contains all the elements whose octet are already complete. So likewise, we have group 1 to group 18, right? 1 and 2 group. 1 and 2 group comes under S block, and group number from 13 to 18 come under P block, and from 3 to 12 is a transition element group which consists of metalloids. Like this. This was the whole, it was the body of the modern periodic table, and here lies the rare earth metals, that is this was the D block, transition block, and here lies the elements of F block called as lanthanides and actinides. Started with lanthanum and actinium. So it was the body of this. So here lies the metals, here lies the non-metals, and here lies the metalloids, transition elements which were showing the transition properties from metals to non-metals, and these were lanthanides and actinides, that is the rare earth metals. It comprised of S block, as I told you, it was D block, it was P block, and it was F block. Now the question comes that how many elements were present in each period. So the element present in each period was given by the rule 2n square. So that means the first period consists of 2 elements, second period consists of 8 elements, third period again consists of 8 elements, then 18, 18, 32, 32 likewise. So these 3 were called as short periods and these were called as long period. The last one period is actually incomplete period. but still it will going to get the electrons approximately 32 only. So more than 32. So it is they are actually called the long periods. So these are the short periods and these are the long periods. Now if I give you some element and ask you to assign the position to an element in the periodic table, how you will be doing that? Just look at the board carefully. If I ask you to assign a correct position to the sodium, or if I ask you that what position does sodium has in a periodic table, so look at the board how you are going to tell me the position for that. So first of all, write the atomic number for it, write the configuration. Right. Now, how many valence electron does it have? It has one valence electron, so that means it belongs to group 1. So, how you can tell the group? By looking at the valence electron. If valence electron is 1, 2, then you simply write that the group is 1. If it is 2, you can write the group is 3. But if the valence electron is 3, 4, 5, 6, 7, 8, you have to just add the 10 and write its group. So it groups is 3rd, 4th, 5th, 6th likewise. Where does this 10 comes from? This 10 comes from 2 to 12. They are the 10 elements, transition elements, which show that is why we add 10 to it whenever we want to tell the group of certain element. And moreover, we have you can say the blocks also, the S block, P block, D block also getting involved, that we are adding 10. The reason being, the reason you are going to study in the higher class. So just for your level, you need to know that if an element has 1 electron, it belongs to group 1. If it has 2 electron, it belongs to group 2. And if it has electron, valence electron more than 2, that is 3 onward, you have to just add 10 and write the group number. This is how you are going to tell the group number of the element. And next, when you want to tell the period for that, so how you are going to tell the period? So look, it has got 3 shells, so that means it belongs to the 3rd period. So that means number of shells corresponds to the period to which an element belongs. So this is how you are going to tell the group and the period. So again I am repeating, if you are looking for the group of any element, so that is you just answer it by looking at its valence electron. I have told you if it is 1, 2, it belongs to first and second group. If it is 3 onward, you have to add 10 in it. And if we are looking for the period, so the number of shells corresponds that to which period it actually belongs. So if like we see that it has 3 shells, that means it belongs to the 3rd period. So sodium, with what is the exact position of the sodium? It is group 1, 3rd period, and we know group 1 belong to the S block, so moreover you will be writing the S block. Otherwise, you get to know this S block, P block, D block also, but this you will learn in the 11th standard, that how you get to know that which block it belongs, because it totally depends upon the configuration we are writing, and you don't know how to write that kind of configuration. So you will be doing in the higher class. So up to your level, you just have to remember that the name of the group 1 is alkali, alkaline, halogens or noble gases, and moreover when you are taking up an example, you are indicating a position of certain element. So just write group number by looking at its valence electron, and period by looking at the number of the shells. And if you remember that this group is called as, is given a particular name like this, so just write that it belongs to this. Otherwise you need to remember that 1 and 2 group belong to alkali group, this thing S block, and 3 to this thing 18 belongs to the P block, and 2 to 12 is D, and lanthanides and actinides the F block elements. So this is how you are going to look for the position of the element.